With evolving pressure surrounding net zero actions that will aid in mitigating the effects of climate change, let's take the global warming potential a step further to form another standardised metric. If you're not familiar with global warming potential, I recommend you go and check out our explainer video first. This will set the scene for you. The carbon dioxide equivalent is a standardised value that allows us to compare the impact of individual greenhouse gases. You may have come across it if reviewing government climate agreements, net zero policies, sustainability reports for a business or product, or even when calculating your own individual carbon footprint. The end result will typically be offered up as a value of carbon dioxide equivalent, or CO2e. This value directly takes into account the quantity of greenhouse gas being emitted, meaning it can be used for the likes of carbon accounting, or climate accounting as it's sometimes referred to. Without maintaining a standardised value, tracking the variation in emissions across the different gases and sectors would be an even more complex affair. Carbon dioxide equivalent is based on the global warming potential, so the impact of each different gas is still benchmarked against carbon dioxide, or CO2. So, how do we calculate the carbon dioxide equivalent? It's actually quite simple, because most of the hard work has already been done thanks to the global warming potential value. We start with the quantity of the greenhouse gas we're dealing with, and specifically the mass. This could be measured in kilograms, or sometimes in tons depending on the context. Once we have the mass, we simply multiply this by the global warming potential for that same gas. It's worth noting that the GWP 100 is what's commonly used, although a different time frame could be considered, which is a detail to keep an eye on. Take the example of carbon dioxide. Let's say 1500 kilograms of CO2 has been emitted, so we have our mass. We also know that the GWP 100 for CO2 is 1. We multiply these two values to give us a carbon dioxide equivalent of 1500 kilograms. Straightforward enough. Let's take another example, this time using methane, CH4. Say 300 kilograms of methane has been emitted, and its GWP 100 value is 29.8. This yields a CO2 equivalent of 8,940 kilograms. If an industrial operation happened to emit exclusively carbon dioxide and methane, then those two values could be combined to assess the company's permitted emissions, such as that accommodated by the UK Emissions Trading System, or ETS. Adding those values together would give us a total of 10,440 kilograms CO2 equivalent for all emissions related to that operation. As you can see, as long as we have reliable information on emissions quantities, we can easily calculate a standardized output of CO2 equivalent. What we have is yet again a simple value that is consistent across the board for easy comprehension and comparability. It may not be perfect, as it can oversimplify important details like the effects or atmospheric lifetimes of an individual greenhouse gas. so it should be viewed as a highlight, knowing that more detail might be warranted. Nevertheless, it's a widely used and valuable tool in gaining a snapshot of emissions in a single, easily calculated figure.